Okay, so this video is on tangent lines, and we are trying to figure out what those are. They are pretty important. They are a really big deal in upper level courses, tangent lines. So basically, a tangent line is something that touches a circle once. That's to a circle. A tangent line in general just kind of like talks about um, tangent line just in general is kind of meaning that it's touching just in one place, then it's going off. You ever talk about somebody going off on the tangent? That's kind of a typical thing. I want to show you something that's pretty important to understand about tangent lines. So, like if you were to look at something like this curve right here, okay, and you were to wonder, and you were to say, okay, well, you were to draw on a tangent here, and you were to draw on a tangent here, okay, what that basically, and let's say that's touching there, what that basically is telling you is kind of the slope of that graph at that point. So this is called a point of tangency. Wherever something hits, that's called a point of tangency. It only touches at one point. Point of tangency, point of tangency. So a tangent to a circle is always going to be kind of showing you the slope of the roller coaster, I guess you could say, if you think about it that way. So tangent to a circle is a line that intersects a circle at one point. It doesn't really even intersect it. It touches it just so ever slightly. And a point is really, really a small place. The point of tangency is where the tangent line and the circle intersect, where they hit. So it's just touching at this one point. That's a point of tangency. Tangent to a circle is a line that intersects a circle at one point. So a tangent line in general kind of just shows you the steepness of whatever it touches in a way. So you can kind of imagine if we had like a roller coaster like this, and we looked at tangent lines, that's the steepness of the roller coaster car, right? On that roller coaster. So that's kind of an important thing to understand, especially in higher level courses. All right. And then, we have this theorem here. Let's see if I can get rid of this screen shade. Get this out of the way. Okay. So the theorem says that if a line is tangent to a circle, then the line is perpendicular to the radius. So what is that basically saying? It's pretty much saying that if we have a circle and we have a line that's tangent to it, and I'll just make it touch at one point, okay, and then we draw in a radius, this right here is going to be 90 degrees, 90-degree angle at the point of tangency. So that's important to understand. So if a line is tangent to the circle, then the line is perpendicular to the radius. Okay, so some basic, sorry, that's the same page. So here's a couple quick examples, just some things that we can kind of talk about. So let's know that last theorem is kind of telling us that this is 90 degrees, that this is 90 degrees, this is a quadrilateral. So we know that 117 and x together should equal 180. That's right. So that means that x would equal 63, I think, degrees. So that's what x equals. So right here, over here on this side, I want you to do this as a now you try. Now you try. So pause the video and give that problem a shot. And when you're done, then hit play. Okay, so let's say we wanted to find the distance between the centers of the circles. So how could we do that? I guess there's a couple different ways we could do that, but we're trying to find this distance here. I'm going to draw that in a dotted line. Okay, so we're trying to find this distance. How are we going to do it? I don't really know, but what I would probably do is try to figure out what this is and go from there. I got a right triangle here, definitely. So I could look at this right triangle, and if I drag this over, This is kind of that triangle, right? This is 14, this is 35, and we just want to find this variable right here, this area. So that's going to be, let's see, 35 squared minus 14 squared is what you'll eventually come to from the Pythagorean theorem. And if we do that out, 35 squared minus 14 squared, I don't know those, so I'm just going to do those on a calculator real quick. Just in the saving time here, 1225. And then 14 squared, I think I know that one. Yeah, 196. So if we take 196 from 1225, that is going to be, oh, that definitely is not right. 1225 minus 196. That's 1029. So x squared equals 1029. And if we take the square root of 1029, we get something kind of bizarre, actually. I think it's 32.07 or something like that. So 32.07 was what I got. I'm just double checking that to make sure I don't have a wrong number here. Yeah, that's right. So that's 32, whoops. That's 32.07, so let's just write that down. X equals 32.07. And we have something. So let's say 32.07 is that value, right? And now we've got to keep going from there. So if that's 32.07, so now we have this new triangle here, and I'll draw it this way. Okay, and we'll call this Y. This is 32.07 if you like. And we'll call this value Y, and that's really the value we're looking for. This is 90. So what we could do is actually, the funny thing is that if we take 32.07 square it, we get 1029. So we should use 1029 for that hypotenuse value. You see what I'm saying? So this, when we square it, is 1029. So 1029 is equal to 64 plus y squared. So I'm going to take 1029, and I'm going to subtract the 64, which was the 8 squared, and I have 965. And if I square root 965, I get y equals 31.06. And so that should be the distance between the two centers of the circles, the y, or this distance right here. Okay, so hopefully that is helpful. Let's keep on cruising and see how we can do here. So this says, is ML tangent to point N at L? I don't know if you have this in your workbook, but you should do this in the margin, please. So let's consider this a now you try. And it's pretty straightforward. I mean, if this satisfies the Pythagorean theorem, then you know that it is tangent because it would be a 90-degree angle. So that's what we're looking at. Now you try. So pause the video, give that a shot in the margin. It's not on your handout. Okay, next. So here's a couple things that you want to know. Two segments that are tangent to a circle, so fill that in, form a point outside the circle, from a point outside the circle, sorry, are congruent. So in other words, if this is tangent right here, and this is tangent right here, then what they're saying is congruent. They're saying that this is congruent to this. So please write that little bit in to your notes and make sure you have those two vocab pieces filled in. It's just a theorem. Okay, now a problem. Find the perimeter of triangle ABC. So I guess what I'm saying now is the following. If this is 10, then this is 10. If this is 15, then this is 15. And if this is 8, then this is 8. So triples here. So what are we going to have? We're going to have, I think, from the red, we'll have 20 because we have two 10s there. From the blue, we'll have 30 because there's two 15s there. And then from the green, we'll have 16 because there's two greens there. Sorry, I think I mixed up that color. So that should give us